Okay, so the directions are going to say factor, and the assumption is that you're going to do so completely. Which means you're going to be looking for GCMFs, and then after you've factored your binomials, did you check for a difference of squares? So we're going to do two simple ones, and then we're going to kind of kick it up. So we've got x squared minus 6x plus 8, and what we're looking for is we're going to grab stuff out of the game. So we're looking for a product number. And the product number is going to be the coefficients of the first and third terms. So we're going to actually multiply 1 times 8, and we get 8. So that's going to go here. The sum number is just you're going to grab with the sign the coefficient of the linear term. Okay. Now, I get people all the time say, well, do I have to multiply 1 times 8 to get 8? And the answer is you want to follow a process because you're not always going to have a quadratic term with a coefficient of 1. And you've got to learn to get in that habit of looking for a product number is the result of multiplying two things. All right, so now I got to play the game. What are factors of 8 that add to give me negative 6? Henry?
Negative 2 and negative 4.
Okay. So what that allows me to do is to now rewrite the trinomial. It's still going to have x squared. It's still going to have 8. But what I'm going to change is that I'm going to write two middle terms. And here's a bummer. They're both negative, so I was hoping I might be able to avoid putting a negative in the third spot, but I'm not. So I just go ahead and write it like that. So now I created a polynomial with 4 terms. X squared minus 2x minus 4x, which, by the way, negative 2x and negative 4x go back to the negative 6x. And now I go ahead and I try to factor by grouping. What do those two have in common?
X.
They have an x. And what do the second pair have in common?
Negative 4.
We need to always, if there's a negative, we need to pull down the negative. Okay? So when I factor out 2 from the first grouping, x squared divided, or sorry, that's not a 2. Try this. Oop, hello, that was supposed to be eraser. Try that again. We're pulling out an x. So x squared divided by x is x, and then negative 2x divided by x is negative 2. And then we're going to pull out the negative 4. So you have to have a sign here. What I get is kids just put parentheses and then they get really confused. It should say minus 4. And then negative 4x divided by negative 4 is x. And positive 8 divided by negative 4 is a negative 2. And did we get what we were looking for? Did we get a match? Sure enough. So what we're going to do is go ahead and factor out the x minus 2 as a common factor. And then remember how we get the last guy? We just grab those coefficients. So the second binomial is x minus 4. So the only thing I need to do is double check my binomials to see if they are the difference of squares. Is x minus 2 a difference of squares? No, x and 2 are not perfect squares. How about x minus 4?
4 is.
Okay, 4 is, but x isn't. So this is my answer. Jared?
Would there ever be a situation where the two numbers that you come up with have to be in a certain order?
What do you mean by that?
Like minus 2x minus 4x, if they were different numbers, would they ever have to be in a certain order?
No, you can place those two terms in whichever order you want, but they do have to go in the middle spot. Okay. Personally, and I'm going to give you a suggestion down the line. If you're done, okay, then you're on your own. Then I would try to put the negative in spot 2 and the positive in spot 3 if I get that option. Okay. Just because it makes things nicer. So again, let's look at product number. I'll do my lattice off to the side. And again, we have a 1 times an 8, which gives me a product of 8. So we'll put the product number on top. And then the sum number, all I'm going to do is take the coefficient of the linear term, including his sign. So I get a positive 6. So what are two factors that multiply to give me 8 but add to give me positive 6? Serena.
4 and 2.
A positive 4 and a positive 2. So the numbers didn't change, but the signs did this time. So I rewrite my trinomial, still with the x squared, still with the plus 8. But now instead of writing positive 6x, I'm going to break it into two middle terms. Positive 4x, positive 2x. And then I'm going to just go ahead and factor by grouping. So the first two have an x in common, and the second two have a positive 2 in common. So always put that sign there that's going to help me out. So I have x, and then when I factor it out, I get an x plus 4. And then the next guy, when I pull out the positive 2, I get x plus 4. My miracle does occur. And I get x plus 4 times the x plus 2. Neither of those are difference of squares, so I am done. And I kind of glossied over there being no GCMFs, but the first and last terms kind of give that away. The first term doesn't have a coefficient, the last term doesn't have an x, so there's no way there's something they all three have in common. All right, let's talk about the little gnarlier kind of problems. Gnarly comes from having a coefficient of my quadratic term that isn't 1. So the process doesn't change, I just have to work a little harder. So let's look for the product number. And I'm going to have to multiply 6 times 20, which equals 120. My sum number is the easy one, I love him. He's just the positive 23. Okay, so we're going to play the game. I think I'll do it here. And we're going to have the product number on top, the 120, and close that up. And then the sum number on the bottom, the positive 23. Now, for most of us, we're not too good at these triple digits. So what we're going to do is try to come up with factors that would give me a sum of 23. So what I do is I start with what's obvious. This is a strategy I like to use. It ends in a 0, so 10 and 12. Okay. So the question is, what sum do I get from 10 and 12?
22.
Darn it. I get 22, but I need 23. So I'm going to have to go back to the drawing board. So what I do is I break the factors into more factors. Now 10 is easy because it only has 2 factors. 12 is a little bit more complicated because it has several sets of factors. I'm going to go with 3 and 4, and the reason why I'm going to try 3 and 4 is because I was so close to getting 23 that I think I'm going to try to find factors that are so close that it's going to help me out. So choice 1 would be to pair 2 with the 3, which gives me a 6, and the 5 and the 4, which gives me a 20. But they add to give me 26, so that's not a good pairing. So how about if I multiplied and paired 2 and 4, which gives me an 8, and 5 and 3, which gives me a 15. And bingo, there's my answer. So what I'm going to do is I'm going to take those two guys and put them inside positive 8 and positive 15. So now when I rewrite my trinomial as a polynomial, I still have the 6x squared and I still have the 20, but inside I have a positive 8x and a positive 15x. Now, just to kind of go back to something Jared said, if I wrote plus 15x plus 8x, it's not going to change what I get at all. I'm still going to get the same final answer. So you get a lot of freedom on this. All right, so 2 by 2. See, these guys have, let's see, a 2 and an x in common. These guys have a positive 5 in common. So when I pull out the 2x, 6 divided by 2 is 3, x squared divided by x is x, and then it says plus 2 divided by, or 8 divided by 2 is 4, and the x's cancel each other out. And then I'm going to pull out the positive 5. 15x divided by 5 is 3x, plus 20 divided by 5 is 4. And did we get our little miracle?
Yes.
We did, yes, indeed. And we get 3x plus 4, 2x plus 5. Now, I kind of glossied over again that I had no GCMF, and it's because if you look at the middle term, what kind of number is 23?
Prime number.
Prime. And so there aren't any factors, and then also the 20 didn't have a variable. Okay, let's try another one that's going to be like that, a little ugly. We have 8x squared plus 10x minus 3. So let's start with the product number. We multiply 8 times negative 3 is negative 24. So I'm going to go ahead and write my lattice as well. Then I can put things in straight away. So we have a negative 24. And then the sum number. Let's see, we just pull out the positive 10. Okay, so let's look at this for a moment. I need to come up with two numbers that multiply to give me a negative 24 and add to give me a positive 10. So number one, what do my numbers look like to give me a negative product?
Positive and negative.
I have different signs. Look at the sign of your linear term, the sum number. What sign is it? Positive. So when I have my two different signs and I add them, what did I have more of when I added?
Positive.
I had more positive. So what I tend to do is I put whatever the sign of the linear term is on the left, the opposite sign on the right, when I have a product that's negative. And then when I come up with my two factors, I put the larger factor with the guy on the left. And that I've established that practice. So now I always know what number to pair with what sign, okay? So the larger factor has to pair up with the sign of the guy down here. Now, what are two factors of negative 24 that add to give me positive 10? Hudson.
12 and negative 2.
A positive 12 and a negative 2. Now, most people don't think about those two factors straight away. They think of 3 and 8 and 4 and 6, but you got to go through all the factors. All right, now we're ready to go ahead and create our polynomial. So we have 8x squared and minus 3 are still there, but now we're going to replace the positive 10x with these two factors. Now, when you have the option, put the negative in the second spot and the positive in the third spot, and that will eliminate factoring out a negative. Okay, so that's a strategy I'm going to suggest you guys use. And now we're going to go ahead and factor by grouping. So these two have, let's see, an even, so 2 and an x. And these two, it's a positive 3. So we're going to get 2x times the quantity 8 divided by 2 is 4, x squared divided by x is x, minus 2x divided by itself is 1, and then plus 3. And 12x divided by 3 is 4x, and then minus 3 divided by 3 is 1. So did we get our little miracle?
Yes.
Yes, we did. By the way, what happens when the miracle doesn't occur?
Then we switch on.
You can check if you did something wrong.
Number one, check if you did something wrong.
And if you did everything right, then you could try to switch. Then you could switch the terms to make it so.
You could check your math, and then you could rearrange the equation. If you still don't get a match, then what?
It's prime.
It's prime. Okay? All right, Gabby.
How do you know to put the 12 or the negative 2 first in the equation?
Who wants to answer that question? How do you know whether to put negative 2x or positive 12x in the front? How do we make that determination? Serena.
It doesn't matter.
It actually doesn't matter. Why would I suggest you put the negative 2 first? Lane.
So you don't factor out a negative?
So that your middle term is positive and you won't have to factor out a negative, which is the most common mistake. Okay? Good question, good answers. Let's try another one. So we're on number 5. Y squared minus y minus 30. Okay, so product number. Is going to be 1 times negative 30, which is negative, ooh, that's a lousy 3, negative 30. So let me get my lattice going. Doesn't look like there, that looks like a negative 30. And then my sum number, I just pull the coefficient of the linear term. Now, I don't see a coefficient there, so what is he? So not just 1, negative 1. So now I need to come up with factors of negative 30 that add to give me negative 1. So again, remember, if my product is negative, my signs are different. The sign of the linear coefficient is going to be the sign of your larger factor. So what are the two factors that multiply to give me negative 30 but add to give me negative 1? Justin?
30 and negative 1.
No, that would give me negative, that would give me 29. Hannah W?
Negative 6 and 5.
Negative 6 and a positive 5. So we're going to go ahead and rewrite my trinomial as a polynomial, still with the y squared, still with the minus 30. And again, I have an option here because I have 1 negative, 1 positive. So I'm going to put the negative 1 first and then the positive 1. So y squared minus 6x plus 5x minus 30. Oh, sorry, it's supposed to be y, sorry. See, even I get in the habit of x's all the time. Mr. Cuneo, it's all your fault. He was my algebra teacher. I'll have to Google and see if that guy's still alive. To be honest with you, we were pretty rough on him. He was a little bit on the crazy side when we got there, but taught us how to do math. And these two have a positive 5 in common. So this grouping, we have y times the quantity, y minus 6. And in this grouping, positive 5 times the quantity, y minus 6. So we get our little miracle. And then we factor. So the GCMF is the y minus 6. That's our binomial GCMF. And then we have the y plus 5 joins up the other two. Okay. Got a doozy coming your way. N to the 4th minus 29y squared plus 100. So in last period, kids go, hey, whoa, 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 it's a trinomial square. We got two perfect squares and a plus. This is awesome. Well, what's the square root of n to the 4th?
N squared.
What's the square root of 100?
10.
What's x or n squared times 10 doubled?
10 and 20 and squared.
20n squared. Ooh, we need 29. So that actually is not a trinomial square. As much as we would like it to be, it is not. So let's go through our little route here. Product number
100.
is going to be 1 times 100, which is 100. Goes on top. Sum number, we just pull the quadratic or the linear coefficient, which is negative 29. And now we play the game. What are two factors of positive 100 that give me negative 29? So first thing I notice, I'm going to get two negatives. And what would those two numbers be? Let's see, somebody I haven't talked to. Oh, come on, ladies. Somebody give me two numbers that work for this situation. All I got is some boy. Oh, Carly plays the game. What you got?
Negative 45, negative 4.
Very good. Negative 25 and negative 4. So we're going to rewrite our trinomial into a polynomial. We still have the end of the 4th and the 100 on the either end. And then we're going to plug in the negative. And again, sorry about this, guys. And again, the variable matches the linear terms variable. There's no way to avoid the negative here. So we're just going to have to contend with that. So the first two have, wow, looks like just an n squared in common. What do the second two have in common?
4. Negative 4.
A negative 4 is what we're going to pull out. Okay. So first guy, we get an n squared. And that leaves behind an n squared minus 25. Second guy, we pull out a negative 4. And then we get n squared minus 25. So did we get our little miracle?
Yes.
Yes, we did. And our answer is n squared minus 25, n squared minus 4. So now we have to check to see if we have the difference of squares. Is n squared minus 25 a perfect square?
Yes.
Holy Toledo it is. So we're going to have to take the square root of those guys. Oops, sorry, that's supposed to be a 5. And that's going to give us 2 binomials, n plus 5, n minus 5. Okay, how about the second guy?
Yes.
Oh, dear Lord, double whammy on us. We have another difference of squares. So that binomial becomes these 2 binomials with n's in front, 2's in back, 1 sum, 1 difference. Is n minus 5 a perfect difference of squares?
No.
How about n minus 2?
No.
Done. All right, let's see if we can squeeze in the last one. Last one. 21 minus 4x minus 12x squared. GCMF?
No.
Close. I thought there was going to be a 3, but 4 that blows the whole thing. All right. So we're going to go ahead and do the product number. Ooh. 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 Our product number is 21 times negative 12, which is a whopping negative 252. Egads. Yuck. All right, well, let's get our lattice going and seeing if we can figure this out. Arrgh. So we get negative 252. And then some number, negative 4. Oh, boy. Oh, dear Lord. Check that out. That's just craziness. Okay, so here's what we're going to do. I'm going to work with that negative 252, and I'm going to go back to the factors that I know that it has. Those two. Now, because it's a negative product, that means I'm going to end up subtracting those. So what's 21 take away 12? 9. Okay, I need 4. So I need them to be a little bit closer. Now, there's only 2 factors of 21, 3 and 7. But I have multiple factors of 12, right? So we could start with 3 and 4. So let's see, I could pair up 9 and 28, but they subtract to give me 19, so that doesn't work. I could do 12 and 21, but that gets me what I already started with. So let's eliminate those as choices. Let's try 2 and 6. So 3 times 2 is 6. 7 times 6 is 42, and the difference would be 36. Oh my gosh, we're going in the totally wrong direction. How about 3 times 6 is 18, and 7 times 2 is 14? Winner, winner, chicken dinner, we finally found the match. Now we have to deal with signs. So remember how we're going to do this. We've got a negative and a positive. The bigger factor needs to go with the negative in order to have a difference that's negative. Lordy. So that's going to be the hard part of this, is wading through to the factors. So we get negative 18x, try to put the negative in the second spot, positive 14x. These two have a 3 only in common. Okay, that's what it is. These two have a positive 2x in common. Okay. So we get 3 times the quantity 7 minus 6x. And then we have positive 2x times the quantity 7 minus 6x. Did we get a miracle?
We did.
Yeah.
Oh, yes. Everything all rolled into one. 7 minus 6x times the quantity 3 plus 2x. Only thing we need to check is 7 minus 6x, the difference of squares.
No.
And we are done. Hallelujah.